Alright, it's the last part of 6.2, and we're going to basically just do 2 story problems here and we'll be done. They are going to be a little longer, a little harder, but I have not seen an AP Stats test in a long time, like an exam, that has not had one of these types of questions in the short answer. So they're very important to know. Also, another thing is I know there's probably still some confusion about when do I square the standard deviations, or when do I add, when do I subtract. Hopefully by giving you a couple more examples here, we should be able to know. So, you work at a bank, and know, like the back of your hand, that pennies weight is normally distributed with mean of 2.5 and a standard deviation of 0.3 grams. Alright. Someone comes into the bank with a bag of pennies and says that they want it in cash. They say that there are this many pennies. Whoa, the mackerel. Thus, they should get $125.26. All right, you obviously are not going to count this by hand. You have a little weigher, and you're going to weigh them. So, what should be the mean and standard deviation for the bag distribution? All right. So, if he says there's 12,526 pennies, that means each penny should have a mean of about 2.5. Now, not every penny is going to be 2.5. Some might be a little heavier, some might be a little lighter. And they deviate by 0.03. Alright, now, here's the deal though. Every penny, every single one of these pennies right here can be different than 2.5. So they can fluctuate back and forth. We might have a bag with really low weight. We might have a bag with really heavy weight. So what would be the mean and standard deviation of the bag? So, well, with the mean, I have just a bunch of pennies, and you should literally go, so this is for the bag. I'm just going to go B for bag. Okay, so the mean for the bag would be 2.5. And basically, I have 12,525 of those 26, sorry, of those bad boys. So the mean of the bag is 31,040 grams. Right? Standard deviation. Now here's the deal. Each one deviates. And when each one deviates, each one can wiggle back and forth. You're just going to get more wiggle. Okay? So this is when we have to square everything. Alright? So we're going to take 0.03 squared, and I could just keep going plus 0.03 squared, right? And I could do this 12,526 times, or we could do it by shorthand, and we could just literally multiply by 12,526. Okay, so 0.03 squared times that by 12,526. I get 11.27. Remember, this is squared, so I'm going to square root it, and the standard deviation is about, for the whole bag, only about 3.36 grams. That's just a little bit more than a penny of deviation. That means we can be pretty accurate on how many pennies are in that bag, right? Because even with that many bags or pennies, it doesn't deviate very much. Okay. Alright, so if the bag weighed this many grams, what would you tell the customer? So I'm going to draw a little normal curve here. Now this is the curve. Oh my goodness. Alright, I've got a mouse. You got to forgive me, guys. That's the best I can do. The middle of my curve, where I should expect the bag to be, is at about 3140, right? However, when I weighed it, it weighed 31301. Right? And that's down. That's lower than what I expect it to be. But it still might not be out of the question. So here's what I would do, I guess. I would kind of see and figure out, well, what's the probability down here? You know, like how many more are down there? Because that's, I don't know, that's pretty far down, right? So you could go like this and could do your z-score. And you could do what I got was 3140 minus what I should have got, which is 30. Sorry. Did I mess up on this? This might have a misprint. Hold on one second. Alright, so, sorry, I just had to relook at it again. I meant to not have that 1 in there, I think. It should be 3130. Not 3130 and then another 1. Alright, so let's see. What would this be? So what I got minus what I should have got. Sorry. Guys, it is so stinking late. I'm so tired. I'm seeing spots. Not really. It's what I got, which is 3130. Okay. Woo! That's how much it actually weighed, minus what I should have gotten, divided by the standard deviation of 3.36. Because would you agree that the standard deviation for this curve is 3.36? Now, if I do that, 3130 minus 3140 divided by 3.36, I get a z-score of negative 2.98. That's pretty far down. That's pretty far down. There's very little left over here. That means I'm pretty far away from where it should be, right? There's a lot of stuff up here. That's where it should be. But I'm pretty far away. So what should I tell? Well, I guess some of the stuff that I would tell the customer is maybe he counted a few pennies short, right? Because only like 1 or 2 pennies short. Okay. Am I really going to make that big of a stink though over it? Probably not. But it does seem like he has maybe a few pennies less than what he counted. It might be more like, I don't know. So, anyways, that's just some thoughts. Sorry, guys. This is a question I came up with last night, and it's been a long week so far. All right, let's do this one. This one's actually what it's supposed to be. All right. Mr. Starnes, he's the author of our book, likes between this many and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a regular selected packet follows the normal distribution. So the mean of 1 pack is this, and a standard deviation of this. If Mr. Starnes selects 4 packets at random, what's the probability his tea will taste just perfect? Just perfect. Alright, so I'm not looking for a normal distribution. I don't want just 1 packet. I want the distribution of what 4 packets would give us, like how much. So here is what the distribution looks like, but let's figure out what's the mean of this, okay? The mean of my sugar. So if I take 4 packets of sugar, where's my mean going to be? If 1 packet's 217, I'm going to go 217 times 4 packets, and I would expect this much sugar to be in 4 packets. Right? Standard deviation of sugar. Standard deviation of sugar is going to be 0.08. Remember, every packet can vary, so it's really 0.08 squared, right? Because this is when each packet can vary, right? Every packet could be high, could be low, whatever, and they could overlap, right? And then I have 4 of them, so I'm going to multiply it by 4. So I'm going to go 0.08 squared times 4, and I get 0.0, oh, that was lovely, 0.0256, and that is, remember, that's when it's squared, so I need to square root it. So I'm going to square root it. Told you guys this is a little bit more tricky. And my standard deviation comes out to be about 16. So I would expect 4 packets to be at around this average, which is right in the sweet spot, right? That is right where I want it to be, right in between 8.5 and 9 grams. Okay, but sometimes it deviates by this much. So here's the normal curve, and basically here's the, this is where he likes it, between 8.5 and 9, right? Once we've converted and made a normal curve that fits our needs, all I need to do is now figure out the probability between that. So I'm going to do sorry, not z-scores. I'm going to, yes, z-scores. I'm going to do z-scores of everything, all right? And let me see. I don't know if there's any more writing left here. I've got my mean, I've got my standard deviation, and all right. So you're going to have to figure out the z-scores, what's the probability, and I don't have any paperwork on any of that kind of stuff, but you guys should know how to do z-scores of this. So you're going to go take the high z-score minus the low z-score percentile, and you should be off and running. Okay, well, guys, I'm sorry this one wasn't like the best. Like I said, I am ready to check off here tonight. But just so you know, you are going to see some of these kind of problems. A little tricky to just read this and know exactly what to do. Like if you were in the middle of an AP exam, I understand how you'd be like, how in the world were they supposed to know to do that? But the more practice, the better. And I guarantee you we're going to see some more of this. Alright, so we're going to have a quiz on a Friday, and over all of this stuff, and tomorrow we'll review. So hopefully this has been helpful. Adios, guys.